Given ABCD is a rhombus, complete the following. So we're going to solve some problems with the rhombus. If AB equals 9, then AD equals, well, that's going to be 9 as well. So add this to your notes. And the reason we know AD has to be 9 is that all sides of a rhombus are congruent. All right, let's look at number 2. If the measure of angle 1 is 65, then the measure of angle 2 is also 65. And that's because the angles of a, actually let me write this in a nicer sentence here. The diagonals, try not to be as wordy on my sentences. Diagonals of a rhombus bisect the angles. Right? So the diagonal AC there has divided this larger angle right here into two congruent angles. Measure of angle 3 is 90 degrees. See how easy these are? You don't even have to do any solving. How do we know that has to be 90 degrees? Diagonals of a rhombus are perpendicular. So that's a B. I guess that looks like a B. Let me make it a little bit better. Whoop, there we go. Diagonals of a rhombus are perpendicular, and we know that perpendicular lines meet at right angles. Oops. I started to combine right and white. I don't know why. If the measure of angle ADC, so ADC equals 80. So these, by the way, the 65 and the 80 have nothing to do with one another. The measure of angle ADC equals 80. Then the measure of angle DAB, so I'm going to actually erase that because now we're looking for what would DAB be if angle ADC was 80 degrees. Okay, well, so angle, we're looking for this one right here, angle DAB. Right, so together, angle DAB plus angle ADC equals 180 degrees. And how do we know? Consecutive angles in a parallelogram are supplementary. And a rhombus is a type of parallelogram. Supplementary. Right? So if angle ADC is 80 degrees, if we subtract 80 from both sides, that's going to leave 100 degrees for angle DAB. And the last question is very much like this second question here. If the measure of angle 1 equals 3x minus 7 and the measure of angle 2 equals 2x plus 3, then x equals, right? So we know that these have to be congruent to one another, right? Because that diagonal bisected the angle and created two congruent angles. So angle 1 is congruent to angle 2, right? And so same reason up here. Diagonals of a rhombus bisect the angles, which means they can create two congruent angles. So we have 3x minus 7 equals 2x plus 3. Let's subtract 2x from both sides. So we have x minus 7 equals 3. And then if you add 7 to both sides, there we go, that's a 7. To both sides, x equals 10. So there's our answer right there. All right? And I'm going to do one more problem. Given ABCD is a rhombus, if AC equals 30 and BD equals 40, find the measure of BC. All right, so let's see here. So this whole thing, AC, is 30 whatevers. Right? And something we know about diagonals in any parallelogram is that the diagonals of a parallelogram are bisected, which means they divide each other in half. Right, so that means that AE equals 15 and EC equals 15. BD is 40, so that means, so that's another diagonal, that means that ED, or I guess I'm going to write DE, DE equals 20, and DE, what's the other one? BE equals 20. Right, so now if we look at just this part here, right, so this side here, AE is 15, BE is 20. Well, how does that help us find the measure of BC? Or actually, let me take the different triangle. Not that's going to make any difference here. But I forgot what side we were looking for. But actually, it won't make any bit of difference. So here, this one was 30. That one was 40. So I'll take this triangle. The reason I say it's not going to make any bit of difference, all these triangles are the exact same length. All right, so the exact same measure. They're all congruent. These are 4 congruent triangles. So we know that EC is 15 and EB is 20. Well, how does that help us find BC? Well, now just think about it. What's true about the diagonals? We know the diagonals of a rhombus are perpendicular, right? So that means they meet at right angles. Which means this is a right angle, which means this is a right triangle, right? So triangle BEC is a right triangle. We can solve for BC using Pythagorean theorem. So this is very much like the problems in your homework. Right, so 20 squared plus 15 squared equals BC squared. 400 plus 225. By the way, this is a Pythagorean triple, if you recognize it. So that would be 625 equals BC squared. And the square root of 625 is 25. So this is a Pythagorean triple, 15, 20, 25. That measures 25. By the way, all of these sides would be 25, which is why I said it made no difference which side I used. All of these, this is 20, this is 15, right? So all the triangles are the exact same size and shape. They are congruent. All right, so this is going to be the end of this podcast. In the next podcast, we'll look at squares. Bye for now.